Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 23rd February 2023. The problem statement for today is unique path in a grid. This problem is based on dynamic programming and matrix and has been asked in Uber interview question. So let's now open this problem. Let's first understand this problem clearly. Here it is said that you are given a matrix grid of n into m size consisting of zeros and ones, consisting of values 0 and 1. A value of 1 means you can enter the cell and 0 implies that entry to the cell is not allowed. You start at the upper left corner of the grid, that is 1 1, okay, and you have to reach the bottom right corner. Okay, so we have to start with this grid and we have to reach the final grid, that means nm, okay, such that you can move only in the right or down direction from each cell. Okay, your task is to calculate the total number of ways to reaching the target modular 10 to the power 9 plus 7. Okay, the first note, the first 1 1 and the last LM cell nm of the grid can also be 0. Okay, here it is saying that you are entering into this cell 1 1, but here it is said that it can also be 0. So we have to, so it is said that starting from this end, while entering the first upper left corner, we have to reach the bottom right corner cell. So we have to find the total number of ways to reaching the target cell. So starting from there and this one, but the constraint is that we can only move in right or downward direction. So what we can do here, to this example, so we can start from this one, okay, we can start from this one and we will populate the values whatever is there. See, we have option to move towards the right and towards the downward direction. So whatever is the value there, we will populate for this row and this column in the new matrix that we will be preparing. We will be using dynamic programming to solve this question. So we will create a new array called dp or something like that, and we will populate the values here. If it is 1, then we will populate 1, else we will populate 0. Okay, then what we will do, then for the all other cells we will see that what is the value that if it is 1, then we will see that what was the value to the previous cell, and to that we will add 1. That means to that we will add this value, else if it is 0, then we will totally skip that. So I'll just try to explain this with this example only. So let me just copy this into the notepad. So this will be okay. Consider this is our input, somewhere format, okay, but it's fine. So I'll just increase its font. I'll increase a bit more. Okay, so so here what we will do, we will create a matrix here and we will see if the grid value, this means this grid is there, if this grid value will starting from this one, if it is 1, then we will even in the our output dp and the dp matrix, we will populate it as 1. If it is 0, then we will populate it with 0. So we will do it for first row and first column. So what we will do, so first row, first column, this one we will get, when we will get this 1, we will in our resultant matrix also we will write 1. Then we will move towards the right, that means we will increment the value of I. We will again get 1 here, so we will again write 1 here also. We will again get, we are getting 1, so we are writing here 1. Okay, so in this one, then another option we have to move to the downward direction. So we will first populate this column. So here here since we are getting 1, that means we are allowed to enter the cell. So again we are writing 1. Then for the next one we are again writing 1, because again the value is 1. So till now, till this point, we have seen the starting from this node, we have two ways. One to move towards the right and we reach the last column, and here towards the down and reach the last row. But our option is that our target is to reach the cell n into m. That means the last or opposite corner. If we are starting from here, then this corner. So for this one, once we are done up to this one, then what we can do here for other options, what we will do here, we'll see till now it is done. Now we have to see all other options. See, if we would have got 0 at any place, then from that place only that option is ending. That means we cannot reach here. Suppose if 0 is at this place, then this path is completely discarded, because the entry to that cell is not allowed. So we will be left only with this option, this and this. Okay, so after we have populated this one, then what we will do here, we will check if this in this grid what is the value at this position. If it is 0, then we will not do anything. If it is 0, we will not do anything, so we will just leave it with 0. Okay, so here just one step back, it will be 0. Then again we will move towards the right. Okay, so starting from 1, we are taking each row at a time. Starting from the right, if we are getting 1, so if we are getting 1, so here what we will do, to this value we will see what was the value. That means to reach this cell, how many ways are there to reach I minus 1 cell and j minus 1 cell. See, if we have to reach this position, then either we have to come this way or we have to come this way. So how many ways are there? So we need to add this and this. So it will give 0. This will give 1 way. Okay, so I hope this is clear. So here it will be 1, because till now only 1 way is there. If this was 1, then here it would have been 2, because for reaching this cell, now we have 2 options. But this is not the case. Here it is 0 and here it is 1. That means we are reaching I minus 1 cell and j minus 1 cell, and we are checking that what is the value there. Okay, similarly for this one. So now this is done. So up to this one we have got this one. So now when we are in the last row, then what we will check to reach this cell here. This cell here, it is 1. If it was 0, then we would have discarded it. But if it is 1, then here we will again check. How many ways were there to reach I minus 1 cell and j minus 1 cell. And we will add both of these. So here it will again 1 plus 0 will be 1. Again the same reason, because since we cannot cross this way from this to this, because 0 is there, so we are left with only 1 way. So for reaching each of these cells, only 1 way is there. Now when we are coming to this position, so here interestingly, to reach this position, we will see how many ways are there to reach I minus 1 cell and j minus 1 cell. So to reach both of these cells, we have one option. So to reach this one, we will add 1 plus 1. So here we will get 2. That means to reach this cell, we had 2 ways, one through this and one through this way. So that's why this will be our last population point, and we had to find ways to reach this. So we will simply return the value of this cell. I hope this understanding is clear. So I'll explain it a bit more while coding, that how we are going to the solution. So what we will do, so first we will create here one integer double dimensional array with name dp, and we will initialize it with new int of n and m, because that is the size that has been given in this question. So this is there. Now what we did in the first step, we populated each of the rows and that means each cell of the first row and each cell of the first column with the value whatever is there in the grid matrix. That means if it is 1, then we are printing that means 1, and if it is 0, then we are assigning 0. Okay, so that is the thing we are doing here. So see, when we created this DP, so initially all the elements has been initialized to 0 because we have not given anything. So by default it contains 0. So the first element of in this one, now what we will do? Now we will assign the values there. DP of 0, 0. Here we will first assign the first value of the grid. Okay, so DP of 0, 0 will be grid of 0, 0. Grid of 0, 0 is if it is equal to 1, then what we will do? We will assign 1, else we will assign 0. So we are simply checking in the grid in this question what is the value given in the 0, 0, that is first index. If it is 1, then we are assigning in DP array 1. If it is 0, then we are assigning with 0. So now what we are doing, now we will populate first row values and first column values. So for that we will create a for loop for int I is equal to 0. No, here we start with 1 because 0 is already taken. We have already taken care of for 0. Then I less than n and I plus plus. And here what we will check? DP of I 0. DP of I 0. It will, if again the same thing, if grid of I 0, if grid of I 0 is equal to 1, if grid of I 0 is equal to 1, then here the same thing. What was the value in the previous cell? So it was DP of I minus 1 and 0. I hope this point is clear. So when we are checking for this one, so we are checking that how many ways were there to reach a cell before that. So it was 1, so this also will become 1. When we will check this, then it will say that how many ways were to reach I minus 1 cell. So here it was 1, so that's why it is coming here as 1. Okay, and this we will check if you are encountering 1 in this position, then only. If we are having a 0, that means the entry to the cell is not allowed, so no point in checking the previous cell. The same approach we will take for first column also. So actually the fund of entire navigation is the same. That means we will keep checking the I minus 1 cell or j minus 1 cell, and we'll keep checking. If it is 1, then we'll update that value with that corresponding value. Okay, so here we will give this value as, for column we will give this as j. It will be j less than m and j plus plus. And here we will say, since we are checking for a column, so first it will be row, that means row will be 0 only for all of these cell. So it will be 0 of j is equal to grid of, what is the value in grid of 0 of j, that means same thing at the same location we are taking. If it is 1, then here it will be, what was the value in the previous column? It will be 0 of j minus 1. Okay, so if it is 1, then this, else 0. Here also it will be else 0, else we are assigning 0. Okay, so once this is done, now what we will do, we will now we need to traverse all the remaining cells. So for that, what we will do, we will create a double for loop here. Int I is equal to 1, I less than n, I plus plus, for int j is equal to 1, j less than m, j plus plus, and here we will check if in grid of ij, is equal to 1, that means if any point in reference, if we are saying that if that particular cell is having 1, then what we will do, see till this point, for why we did these two operations separately, because to any of this cell only we had left cell, we did not have any upper cell. Okay, and for this one, for this one we have only upper cell, no left cell was there. I hope this is clear, because for first row no upper cell was there, and for first column no left cell was there. But for all other cases we have both upper and left cell, because since we can move only in right and downward direction, so we have to look one cell in the left and one cell in the up, so that from up we can move down and from the left we can move right. I hope this is very clear. So now for this we need to check for the remaining this and this, we have to check both the values. So that's why we will see, we will check if it is having 1, then entry is allowed, and then we will add these and the previous I minus 1 cell value and j minus 1 cell value, because now we have two options there. So we will populate the value of I j, if it is 1 only, then only, if it is ij is equal to dp of ij is equal to dp of I minus 1 and here j, plus dp of I here, and here it will be j minus 1. Okay, so here if we are at this point, so here it is 0, then it is in this calculation will not happen. So here if we are here, and this grid of ij is equal to 1, then what we will say, for populating this value in dp, respective value in dp, we'll check the previous value in dp with I minus 1j, that means I minus 1 previous value with us in the same column, and in same row previous cell, this and this. I minus 1 will point to this, I minus 1 and the j is same, so it will point to this cell, plus I will be same, that means row will be same, and j minus 1 will point to this cell. So it will be summation of 1 plus 0, it will be 1. So that is only this point. And here it was said that for reaching all these things we need to do the modulus using this number. Modulus using this number is done to avoid any kind of integer overflow when the large number will be taken into consideration as an input. So that time it may happen that integer overflow error might happen. That's why we need to restrict it with this within the given integer value range. That's why we are doing this one. So it will 10 to the power 7. So 1 2 3 1, so 10 to the power 9, 1 2 3 4 1 2 3 4 5 6 7 8 and 10 to the power 9, and so 7, it was 7, so it will be 7, modulus 7. Okay, so once this is done, once this both for loop is done, then here what we will do, here we can simply return dp of n minus 1 and m minus 1. See, here n and m was given 3. So here the first cell will be 0, 0 and the last cell will be 2 and 2. So that's why it is n minus 1 and m minus 1. So n minus 1, 3 minus 1 will be 2 and m minus 1 will be 3 minus 1 again will be 2. So dp of 2, 2, it will represent this corresponding value in the dp which was there. This is our dp array. This is our dp array. This was our input array. So we will return this value as 2. Okay. So I'll just explain the entire thing once again here. So here this method is taking the two-dimensional array grid as an input, which represents the grid value in zeros and 1, and this will represent this returns an integer value representing the total number of ways to reach the bottom right corner of the grid from top left corner, given that you can only move in right and downward direction from every cell. So here what we are doing, the first step here is to determine the number of rows and number of columns, that is already given here n and m. So subsequently what we will do, we will create a 2D array, that is we are calling a dp, of size n by m, which is used to store the number of ways to reach each cell in the grid. The dp array is initialized to all zeros. So here it will be initialized to all zeros. In the first element of the dp array, that is dp of 0, 0, is set either to 0 or 1 based on whether the top left cell of the grid is accessible or not. So based on that only, whatever value was there, based on that only we are setting this dp of 0, 0. This is done using a ternary operator. If the value of the top left cell is 1, then dp of 0, 0 is set to 1, else it will be set to 0. So next we are creating two loops, and these are used to fill first row and first column of the dp array. The dp of I and 0, dp of I is 0. Element in the dp array represents the number of ways to reach cell I0 in the grid. If the value in the cell I0 of the grid is 1, then dp of I0 is set to dp of I minus 1, 0. That means in the previous step, that means in the previous value of row, that means previous value of I, which represent the number of ways to reach the cell above it. If you consider at any point I minus 1, then the number of ways to reach a cell above it. Okay. Otherwise dp of I0 is set to 0. Similarly for dp of 0j, the element of the dp array represents the number of ways to reach cell 0j in the grid. If the value in cell 0j of the grid array is 1, then dp of 0j is set to dp of 0 and j minus 1, which represents the number of ways to reach a cell to the left. Otherwise dp of 0 is set to 0. I hope till this it is very clear. Now finally we are running a nested loop which is used to fill the remaining cell of the dp array. For each cell I and j in the grid, if the value of the cell is 1, the number of ways to reach that cell is the sum of the number of ways to reach a cell above it and the number of ways to reach the cell to its left. The same thing I was explaining. If we are finding the number of ways to reach this one, that will be the number of ways to reach a cell above it, and to this we will add the number of ways to reach a cell to its left. So this 1 plus 0 will be 1. So that only we are doing in each step. This is because you can only move in the right and the or the downward direction, so from every cell. So the number of ways to reach a particular cell is the sum of the number of ways to reach a cell above it and the number of ways to reach the cell to its left. Then the whatever result we are getting, that we are doing a modulo with this number. Then finally simply it will return the value stored in dp of n minus 1 and n minus 1, which represents the total number of ways to reach the bottom right corner of the grid from the left top corner. So in this one we have used the overall approach of dynamic programming, which is common technique for solving problems where you need to break down a complex problem into smaller sub problems by storing the number of ways to reach each cell in DP array. Whatever the code we have written, it will avoid recomputing the same subproblem repeatedly, which has led to a efficient solution. Okay, so now let's try compiling this code, whatever we have written. So we can see we have got our output correct. So now let's try submitting the solution. So here we can see we have got all the test cases passed and we have solved this problem successfully. Yeah, so that's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.